Now let us consider how to determine the equilibrium constant, Victor, from Nernst equation. Pranav, are you able to follow?
Yes, sir.
Yes, sir.
Is the screen displayed to you?
No, sir.
No, sir.
It's not.
No, sir.
No,
No.
sir. No.
Is it okay now?
Yes, sir.
Yes, sir.
Yes.
Yes.
Right. We can determine the equilibrium constant. So, what is this equilibrium constant that is represented by K? Let me consider A plus B that undergoes equilibrium to give C plus D. Let us take some reactants and products. Let me say that is a X amount of A and Y moles of B react to form L moles of C and M moles of D. And according to law of mass action, the product of the active mass of the product divided by the product of the active mass of the reactants is always a constant. So the ratio between the product of the active mass of the product and the product of the active mass of the reactants remains constant, and that constant, when it is based on concentration term, it is called Kc. When it is based on partial pressure, it's called Kp. So these things we have already studied in our chemical equilibrium or in thermodynamics. Now let me represent this C, and this mole should be given in power. So C power L. Okay. And what about this D power M divided by B power A power concentration A power X concentration of B power Y. So actually this is called active mass of C that is proportional to the concentration of C. And introducing the L power, it becomes power L power L. And since these are all some strong electrolyte, we can say this active mass is fully involved as concentration. So this is replaced by the concentration term, okay, of C. And that is why instead of putting A, I put concentration terms. Is it clear? So this is called equilibrium constant. What is K? Equilibrium constant. And what is this law associated? Law of mass action. Okay, right. Now we are able to find out the equilibrium constant from this Nernst equation. Okay, how? Now let us consider the cell reaction. Zn reacts with copper 2 plus in an aqueous form to give Zn 2 plus aqueous plus copper in the solid form. Usually the active mass of the solid or any metal concentration is taken as unity, that is 1. Okay. Therefore, the equilibrium constant for this reaction can be the concentration of Zn2 plus into the concentration of Cu divided by the concentration of Zn into the concentration of Cu2 plus. Okay. So in that case, we can eliminate this Cu, so because they are solids. So Zn2 plus concentration divided by Cu2 plus concentration. Okay. So this is the equilibrium concentration, equilibrium constant. Okay. Now we know the cell EMF is given by Nernst equation. is E naught cell minus 2.303 RT divided by NF into log to the base 10 of here Zn 2 plus divided by Cu 2 plus. Since two electrons are involved, n is equal to 2, so we can replace this by 2 in the next step. Okay. So, and in this case, at equilibrium, take down at equilibrium. What do you mean by equilibrium? When the rate of the forward reaction is equal to the rate of backward reaction. At that stage, the E cell EMF will be zero. Okay. At equilibrium, cell EMF is a zero. Right? Therefore, we have that is E naught cell minus, and this E cell is zero already. So E naught cell minus 2.303 RT divided by 2F into log of Zn2 plus divided by Cu2 plus. And why I put zero? Because we are declared at the equilibrium, the cell EMF is zero. So this E naught cell can be brought here. Okay, so this becomes plus. Therefore, E naught cell is equal to, right? And you can reduce this equation because we know R is equal to what? 8.314. You must always write as frequently as possible so that you will not forget the value. So what is the value of R? 8.304 Joule per Kelvin per mole, right? Then what about the room temperature? 298 Kelvin. And what is the farad value? 93,487 coulomb. So we can replace all these values so that you are able to get 0.059 divided by, and you got 2. So put 2. Okay. So that is the into log of. Okay. That is log of. And this term can be called Kc, is it not? So you can simply put Kc, okay, right? Now, so for this E naught cell value, it is given as 1.1 volt. That will be given to you. So E naught cell value of this cell, which cell? This zinc and copper electrode cell is 1.1 volt. That is given value. Okay. So you can replace this by 1.1. Okay. Is equal to 0. You can make this as a 0.6 divided by 2 into log of AC. Okay. Now you can bring here 2.2. So you have 2.2 divided by 0.06, right? That is equal to log AC. Do you understand? And now you can make it as 20, 220, multiply and divide by 100. So 220 divided by 6. That is equal to log, what is that? Kc. Therefore, log Kc is equal to, so what is the value of uh, 220 divided by 6? 220 divided by 6. So 36.67. So 36.67. Okay. So this is 36.67. Right. Now, what you're supposed to do, you have got already this Kc, you have to find out Kc. So take the inverse of log, that is nothing but anti-log of, take the anti-log of 36.67. So what is the anti-log of 36.67? Do it. 0.67. What you are supposed to do? Take the 0.67 anti-log. How much? You should not say 4 point. Anti-log. 67 zero level. 4677 7 are you anti-log, not log, anti-log. So 4677, is it not? So this is 4.67 into 10 power, and whatever the value you have, it should be written here, power 36. Okay. So 4.67 into 10 power 36. So 4.677 into 10 power 36. So this is the value of Kc. Okay. But in your book, it is given as a 2 into 37. Shall we check once again? Is it okay? 0.066. 0.06 and 2. So, huh? E naught value is 1.1 only. No, no, no. That is given. 1.1 volt is given. That is the E naught set value. So I put in 1.1 and then 0.059. Instead, I have put a 0.6 divided by 2 into log case. That is correct. So it means a 2.2. Is it not? So 2.2 divided by 0.06. That is also correct. Then I have multiplied by 100, right? So 220 and here it is 6. So that value is 36.67. That is correct? So 36.67. And you have to consider the log of 36.67. So in that case, you have to put 0.67. Okay. So it gives 36, I mean, 0.67, 4.4677. That is 4.67 into 10 power 36. So it's about 36. We are correct. So our answer is correct. Okay.